In this lesson, we will understand what is the OpenCV Python library. With that, we will see why it is used, how you can use it with the features. Let us start. OpenCV, that is the open source computer vision library, is a widely used open source toolkit for computer vision and machine learning. Originally created by Intel, it is now maintained by the OpenCV Foundation and a global community of developers. The library offers a rich set of functions and tools designed for building real-time computer vision applications. In simple terms, OpenCV is like a toolbox that helps you work with images and videos in Python. With it, you can detect faces, track moving objects, apply filters, and much more. How it works? OpenCV is written in C++ for speed and efficiency, provides bindings for multiple languages including Python, Java, and MATLAB. It is optimized to leverage multi-core processors and hardware acceleration, making it ideal for real-time tasks. Why it matters? OpenCV is one of the most popular and powerful libraries for computer vision. Whether you are experimenting with image filters or building facial recognition systems, OpenCV is the go-to choice. With OpenCV, you can even work on advanced projects like self-driving cars. OpenCV is a widely used free and open source toolkit used for computer vision and image processing algorithms, as we saw before. It offers more than 2.5K, that is 2500 optimized algorithms that enable tasks such as face detection, object recognition, motion tracking, and many other vision related operations. Beyond Python, OpenCV also supports other programming languages like C++ and Java, making it versatile and accessible for developers across different platforms. Let us see the features of OpenCV. The first one is image processing. Perform essential operations such as filtering, edge detection, color space conversions, and morphological transformations to manipulate and enhance images. Video analysis. Analyze video streams with capabilities like motion detection, object tracking, and background subtraction for dynamic scene understanding. Feature detection and description. Utilize advanced algorithms like SIFT, SURF, and ORB to identify and describe distinctive features within images for tasks such as matching and recognition. Next is object detection. Leverage pre-trained models and frameworks to detect faces, objects, and other visual elements using modern deep learning approaches. Machine learning. Apply classification, clustering, and regression tasks by combining OpenCV with machine learning algorithms for intelligent image and video analysis. Next, camera calibration and 3D reconstruction. Access tools for camera calibration, stereo vision, and 3D reconstruction to build accurate spatial models and depth perception systems. Deep learning. Seamless integration with popular frameworks like TensorFlow and PyTorch, enabling the use of pre-trained models or custom neural networks for advanced vision applications. GUI and visualization. Create interactive windows, display images, and manage user input with built-in functions that simplify visualization and debugging. Let's see why we use OpenCV. Easy to use. OpenCV offers intuitive yet powerful tools that make handling images and videos straightforward even for beginners. Wide range of applications, whether it's a simple photo manipulation or cutting-edge AI projects, OpenCV provides the flexibility to tackle tasks across the entire spectrum of computer vision. Community support. Backed by a global community, OpenCV comes with extensive tutorials, sample projects, and open source contributions, ensuring you will always find guidance and inspiration. Now let us see what can you do with OpenCV. OpenCV is a powerful computer vision library that unlocks a wide range of possibilities. With it, you can work with images, read, display, and save images effortlessly, edit images, resize, crop, rotate, or adjust colors to transform your images, Apply filters, enhance or analyze images using techniques like blurring, sharpening or edge detection. Detect objects, identify faces, eyes, vehicles and more with built-in detection algorithms. Track motion, you can easily monitor and analyze movement in videos. Build AI models, create models for advanced tasks such as facial recognition or autonomous driving. How does OpenCV work? OpenCV operates by offering a rich set of functions that developers can use directly in their code to handle image and video processing tasks. Its workflow typically follows three main steps: reading an image, import visual data from a file, camera or stream into your program, processing the data, apply transformations such as filters, edge detection, face object recognition or color adjustments. Last, displaying or saving the output, show the processed result in a window or export it back to a file for later use. In short, OpenCV acts as a toolkit that simplifies computer vision tasks by giving you ready-to-use functions for loading, analyzing and outputting visual information. Now finally, let us see the key takeaway. OpenCV is one of the most powerful and flexible libraries for computer vision. It simplifies working with images and videos and serves as the backbone for countless cutting-edge AI applications. Mastering OpenCV unlocks a world of innovation, whether you are building creative projects or solving complex technical challenges. In the upcoming lesson, we will walk through how to install OpenCV with pip and configure your environment to get started. In this lesson, we saw what is OpenCV, why it is used, why it is so popular. With that, we also saw its features and capabilities.